2.5. Solve linear inequalities in one variable. This sessions we will review solving linear inequalities from Math 115, which is elementary algebra. The main thing that you need to learn is how to write the solution in 3 different ways. So first off, we want to recall, okay, if I give you an inequality, which is x is less than 4, how do we graph it, the solution of it? So there are many solutions for x at the value of x that is less than 4. So the way that we graph will be, here's a real number line, and here's 0, and here's 4. And since x is less than 4, 4 is not a part of the answer. So we use open circle to represent that number 4 is not a part of the answer. And now we need to indicate which side is the solution. So x is less than 4, so it must be 0, -1. Those are the value that smaller than 4. So I arrowed it this way. So to present less than value, we use open circle. Interval notation is basically right from the smallest value to the largest value of the solution set. So according to this graph, our smallest value is the negative infinity, because if we keep on going. So we started with negative infinity all the way to 4. Negative infinity or positive infinity, we always use parentheses. For less than or greater than, we need to use parentheses to indicate it is not inclusive. So for less than, we have to indicate that 4 is not included by using parentheses. So that's very important. Okay? Set builder notation is writing the answer in this format. Okay? So it will be an open set, the variable that we are solving for, which is x, such that, and then we will write down the solution. Now the solution can be in descriptive form or inequality form, and some other type. But however, for this sections, we will only use inequality form. So therefore, my answer will be x is less than 4. Similarly, if you look at the next case, which is greater than or equal to, so this is the case how to represent when equal to involved in an inequality. So for this one, let's draw a real number line. Since k is greater than or equal to -2, so here's -2, here's 0, and 2 represents greater than or equal to or less than or equal to, we use a closed circle. And now the value of k is greater than -2, so it must be 0, 1, 2, 3. So we draw the arrow on the other side to indicate that. Interval notation, once again, we are writing the smallest value to the largest value. So in this case, in a solution set, the smallest value is -2 to positive infinity. And once again, negative infinity or positive infinity is always using parentheses. But to indicate -2 is a part of the solutions, we have to use a bracket. So now you can see the difference between the usage of parentheses and bracket. So you have to be careful with that. Okay. And finally, the set builder notation is a set of k such that k is let me erase that. K is greater than or equal to -2. Okay. Now, as you can see right now, this is basically going to each side. Now, what if the variable is trapped between two numbers? So look at the last inequality. negative 2 is less than or equal to t less than 4. So to graph this, here's a real number line. Here's negative 2, 0, 4. Negative 2 is inclusive because it's less than or equal to, so we put close circle. 4 is not inclusive, which is less than. So our value t is between these two numbers. That's our graph. So finally, if I write in interval notation, the smallest value will be negative 2 and the largest value is 4. So we need to indicate those endpoints are inclusive or not inclusive. So negative 2 is inclusive, so we use bracket, and 4 is not inclusive because it's less than, right? Less than 4, so it'll be parentheses. So finally, set builder notation will be, as usual, a set of t such that negative 2 is less than or equal to t less than 4 close set. So now that we review 3 different ways of writing the solutions, we will continue reviewing how to solve inequality. Now, solving inequality is very similar to solving equations. You can add, subtract to both sides of inequality by any numbers. But however, one rule change from equation is this. Whenever you divide or multiply both sides of inequality by a negative number, the inequality symbol switch it around, which is reverse it. Okay? So let's take a look at on example 1. We are interested in solving inequality 4 minus 2x is greater than 16. So solving as usual in equations. So first, subtracting 4 to both sides, that will give me negative 2x is greater than, subtracting 4, so that will become 12. Now, we need to divide both sides by a negative 2 to isolate x. So x, when you divide or multiply by a negative number, that's where the inequality symbol switch it around. So therefore, I switch my inequality at this point. So x is less than negative 6. So once we got the answer, we're going to write in 3 different ways. First, graphing. So here's my real number line. Here's negative 6. Here's 0. X is less than negative 6. So this inequality symbol indicate that we have to use open circle, which is not inclusive. The value that is less than negative 6 will be negative 7, negative 8, so it'll be going to this directions. Now that we know the graph, we can base off on this graph quickly write the interval notations. So interval notation is always smallest value to the largest value, so it'll be negative infinity to negative 6 as usual. Negative infinity or positive infinity, we use parentheses. Now the other endpoint negative 6 is not included, right, because of the less than inequality, so we use parentheses. And finally set builder notation, which is a set of x such that x is less than negative 6 close set. So that will be our answer. Next example. So In this example, is a little bit more like stuff to do. First, we're going to distribute this 8 to both of the term, which will give me 6u plus 8u minus 8 is less than or equal to 10u plus 32. A little bit of technical difficulty right here. So now, on the left-hand side, combining like term, 6u plus 8u is 14u minus 8 is less than or equal to 10u plus 32. So isolating the variable, so I subtract 10u on both sides, so this gives me 4u minus 8 is less than or equal to 32. Adding 8 to both sides, which gives us 4u is less than or equal to 40. So finally, we divide both sides by 4 to get our final answer. And since we are dividing by a positive number, the inequality symbol does not switch. So it will be u is less than or equal to 10. So graphing it, here's 0, here's 10. Since the inequality is less than or equal to, right? Less than or equal to, that means this endpoint 10 is inclusive, and then we represent that by a closed circle. And since u is less than 10, so that must be 0 and negative number. Now, we write interval notation, which is negative infinity to 10. And as you can see, I already put a parenthesis on the infinity already because it will be always used that. But 10, the endpoint is inclusive, so we have to use the bracket to indicate that. And finally, set builder notation will be a set of u such that u is less than or equal to 10 and close set. And that will be our final answer. Next question. So very similar to the previous one, we're going to solve it first. So solving it, I need to distribute -3 to both of the term, and on the right hand side distributing 5 to both of the term. So that gives us 4c minus 9. -3 times -c will be positive 3c. It's greater than 5c minus 30 plus 2c plus 2c. Then simplifying on both sides, which is -9, 4c plus 3c will be 7c, greater than 5c plus 2c will be again 7c. Now, if we subtract 7c to both sides, this is what we get. -9 is greater than -30. It's very similar to the situation that we saw in equations, right? The variable that we are solving for got eliminated. Now, what we need to do is we need to decide it based on the leftover statement. What is this statement? -9 is greater than -30. That is true. That is true. So what does that mean? That means what we have many solution. So how do we write many solution, or how do we graph many solutions? So first graphing, here's a real number line, 0, and that means what all the value is in will be the solution. That's how we represent it. Interval notation, according to the graph, you can see that it will be going to negative infinity and all the way to positive infinity. And since infinity, we use parentheses. So that's how we represent many solutions in interval notation. And lastly, set builder notation will be open set. The variable that we are solving for is c, such that c is equal to all real number. Now, so you can spell it out, all real number, or you can write this symbol, R with double bar. That is a notation for all real number. The next example, example 4. This time we have fractions, so we know that if we have fractions, we basically clear the fraction first, like we solve an equation. So LCD in this case is 4, 12, 6, 8, so it'll be 24 is my LCD. So I multiply the left hand side by 24 and the right hand side by 24 to clear the fractions. Okay. So when you multiply by 24 is basically you're going to be distributing it after that, right? So when you distribute it, all the fraction will be eliminated. So 24 times 1/4, that will be 6y. Again, you can do side work like I showed you in equations, solving equations, right? That will be 24 over 1 and then times with 1/4. So 4 goes into 1 time, 4 goes into 24, 6 times. So that's how I got 6y. Minus 24 times 12. 12 goes into 24 2 times, so it will be 2y is greater than. Now, we're distributing this. 24 goes into 6 and then 7, right? So 24 times 1 6, which was going to be 6 goes in 24 4 times, so it would be 4y plus 8 goes into 24 3 times. 3 times 7 is 21. Now continue simplifying it. On the left hand side, 6y minus 2y is 4y is greater than 4y plus 21. And subtracting 4y to both sides, that will become 0 is greater than 21. So obviously is opposite from the previous example, right? Because the leftover statement in this case is false. So what does that mean? That means no solution. So how do we represent that no solutions? Graphically, basically you are graphing nothing, so it will be just a real number line with nothing on it. And interval notations, no solution, you see that already, it's just no solution. Or set builder notation is basically a set notation with no answer in there, so we call it empty set like this. So that will be our final answer for this problem. Translating inequality is important. A lot of us need to remember these keywords because it used a lot in statistics, right, the next course. So we really need to know what is how do we interpret these keywords using the inequality symbol. So take a minute to look at that, those keywords, right? And we're gonna start example 5. It said that 19 less than p is no less than 47. So in this case, no is no less than is the key words for inequality symbol. And as in equations, inequality has the left-hand side and then the right-hand side. So this is my left-hand side of inequality, and this is my right-hand side. So we're going to translate these phrases first. Less than is something that you have to be careful when you translate because it's flip around. So P less than less 19. Sorry, 19 less than P is P minus 19. And then on the right hand side is 47. Is no less than, right? So that means the value cannot be less than 47, means the value must be greater than or equal to. So here's right here, no less than, right? Next example, example 6. 4 more than A is at most, is at most. That's the keyword for inequality. And here's my right hand side, here's my left hand side. So let's translate these phrases. 4 more than, so more than is another keyword that they flip around. So it'll be what? A plus 4. Okay, A plus 4, that's my left hand side. And then on the right hand side, nothing to translate, so it'll be just 15. So it said that the left hand side value is at most 15. So you cannot go past 15, which is that means it must be less than or equal to at most. Right? It can be at the most you can go is 15. And that will end this sessions.